Try to do this question on your own before you look at this video. So it says in setting environmental standards. Okay, so we are setting environmental standards for industry and others, so probably households, industry and others. In setting environmental standards for these guys to meet, it is inadvisable. So it is something not to be advised to require the best results that the state of the art technology can achieve. Okay, so when you are setting environmental standards, it's not recommended that you require the best results that the state of the art technology can achieve. Okay, if state of the art technology, let's say, can achieve whatever X, so that is the best result. So it's not recommended that you require that from the industry and others. Okay, current technology is able to detect and eliminate. Okay, so current technology, now we're talking about current technology, is able to detect and eliminate even extremely minute amounts of contaminants. Okay, so the current technology is really good. It can eliminate extremely minute amounts of contaminants, but at a cost that is exorbitant relative to the improvement achieved. Okay, so let's say you are able to eliminate very small amounts of contaminants also. Let's say whatever the unit is, let's say you are able to eliminate uh, zero point 0.1 size of contaminants. Okay, even the contaminants which are of size zero point 0.1, I'm just taking an example. You are able to eliminate that, but it's coming at a cost that is exorbitant, which is a lot relative to the improvement achieved. Let's say if you have to eliminate even these small contaminants, you have to spend 100 rupees. But if you have to spend, let's say if you have to just eliminate till this, so if you eliminate till zero point 0.5 size, it means zero point 0.4, zero point 0.3, 0.2, 0.1 and all that. Anything smaller than this size will remain there. Okay, so you are eliminating contaminants of this size, but smaller contaminants will stay there. This is more precise, right? You are eliminating till 0.1. Okay, we are, let's say that is extremely minute amount. So now this may cost, let's say, rupees 10. So if you think about it, if you move from point 1, zero point 0.5 to zero point 0.1, you are really eliminating more contaminants, very small contaminants also. But the cost is pretty high, right? It takes just 10 rupees to eliminate these contaminants, right? These contaminants means still zero point 0.5. So zero point 0.6, 0.7 you are able to eliminate, but zero point 0.4, 0.3 you are not able to eliminate. In this case, you are able to eliminate till zero point 0.1. So anything that is bigger than zero point 0.1 will be eliminated, but it costs a lot. So current technology is able to eliminate even extremely minute amounts, but at a cost that is exorbitant relative to the improvement achieved. Relative to the improvement achieved means it is not a very significant improvement compared to the difference in the cost. And if you think about it, the second statement is giving us a reason why it is inadvisable to require the best results, because it's coming at a very high cost, right? These are the best results we can achieve with the current technology, but it's very expensive. Okay, so it would be reasonable instead to set standards by taking into account all of the current and future risks involved. So the author is saying just requiring whatever the best we can do is not really advisable, because it can cost a lot. Okay, we can eliminate, let's say, point 0.1 also, but it's going to cost a lot. So why don't you rather go for uh, rather set standards in a way that takes into account not the best result, but essentially your risk. Let's say you uh, let's say you don't need to eliminate, let's say, zero point 0.1. It doesn't pose a lot of risk. Let's say anything higher than zero point 0.3, zero point 0.4, let's say zero point 0.3, really is causing either current risk or future risk to your health or something else, then set standards in according to this. So essentially, in that case, set standards that okay, anything greater than this has to be eliminated. Anything greater than this size. Now, in that case, this may cost the industry rupees 50, for example, right? So the industry is still able to save the unnecessary expense that it could have incurred by just going for the best, right? In this case, it is, let's say I'm saying this is somewhere in the middle, right? It's not the best. So that is what the author is saying, that rather than just going for the best, why don't you just take into account your current and future risks involved, then accordingly set standard rather than just thinking okay, point one is one what I can achieve, so let's make the standards point one. Okay, this is the argument. So before you jump onto the options, of course, this is extremely important that you understand the argument. If you have not understood the argument, then there is no point evaluating the options, right? You're just shooting in the dark. So this is what this is. Now you may not have these numbers in your mind. It doesn't mean that understanding this requires understanding of these numbers, but the point is the idea should be absolutely clear what is exactly happening. Okay, the argument given concerning the reasonable way. So this is a reasonable way to set standards presupposes. So we are looking for an assumption. What does it presuppose or what does it assume? Industry currently meets standards that have been set by environmental authorities. So it's talking about whether the industry currently set meets the standards, right? Now the whole point in the argument was how should we set standards? Whether we should require the best or actually we should just take into account current and future risk, then accordingly set standards, right? So the discussion was how to set standards. It does not really matter whether the industry is currently meeting the standards or not meeting these standards. We don't even know what the correct standards are, right? The current standards could be requiring this or the current standards could be requiring this, the reasonable way, right? We have no idea what the current standards are. We're just debating, okay, this is not the best way or this is not ideal to require the best results. This is a more reasonable way. Okay, so this has no impact. There are effective ways to take into account all of the relevant risks posed by different levels of contaminants. Okay, so if there are effective ways to take into account all of these risks, then yeah, the reasonable way is something that we can execute, right? That we can take into account all of the current and future risks involved. So it supports that at least this is possible, that we can execute this reasonable way. If we negate it, there are not effective ways to take into account all of these risks. If there are not effective ways, then how is this reasonable? Then we can't even execute it, right? In that case, it may make sense to just go with the best, right? Just go with the whatever the state of the art technology can achieve, because we can't take into account all of these risks. Okay, so this is a strengthener and its negation breaks down the argument. So this is an assumption. Option B is the answer. The only contaminants worth measuring are generated by the industry. So, so the only contaminants worth measuring. So let's say there are only three contaminants worth measuring: A, B, C. The only contaminants worth measuring. So these are the only contaminants worth measuring: A, B, C. Are generated by the industry. Again, it doesn't really matter whether A, B, C are generated by the industry or not. Whether only A, B or A, B, C, D are generated by the industry. Okay. This does not matter, so it's no impact. It is not costly, so it's a negative statement. So I'll negate it right away because dealing with positive statements is easier. So it is costly to prevent large amount of contaminants from entering the environment. Okay, so it is costly to prevent large amount of contaminants. So it is a so to prevent the large amounts. right? Here we were talking about extremely minute amounts. Now here we are talking about to prevent large amount of contaminants from entering the environment is costly. So this is costly. Okay. So okay, that we were talking about how minute we should go, right? Now large amount of contaminants, preventing this is also costly. That is fine. This is costly, but our point was this is really exorbitant relative to the improvement achieved. Okay, so even preventing large amount of contaminants may also be expensive or may also be costly, but still I think it makes sense. The argument still holds that you should stop at point 3 and not go to point 1 because the cost is exorbitant. Okay, it's going to be even much higher. So this does not break down the argument. So this is not an assumption. The negation is not breaking down. Option E, minute amounts of some contaminants can be poisonous. Minute amounts of some contaminants can be poisonous. First of all, if you think about it, it's saying even minute amounts can be poisonous. So it's not even supporting, right? If you look at it, minute amounts can be poisonous. If that's a scary thing to know, right? Then it may make sense to really go with the best results, right? To not make any compromises, right? So it's not even strengthening. Since it's not even strengthening, we can reject it outrightly, and so option B is the answer.